Because samples of matter typically contain so many atoms, a unit of measure called the mole has been established for use in counting atoms. For our purposes, it is most convenient to define the mole as the number equal to the number of carbon atoms in exactly 12 grams of pure carbon. Techniques such as mass spectrometry, which count atoms very precisely, have been used to determine this number as 6.02214 times 10 to the 23rd. The number is called Avogadro's number, to honor his contributions to science. 1 mole of something consists of 6.022 times 10 to the 23rd units of the substance. Just as a dozen eggs is 12 eggs, a mole of eggs is 6.022 times 10 to the 23rd eggs. The magnitude of the number 6.022 times 10 to the 23rd is very difficult to imagine. To give you some idea, 1 mole of seconds represents a span of time 4 million times as long as the Earth has already existed, and 1 mole of marbles is enough to cover the entire Earth in a depth of 50 miles. However, since atoms are so tiny, a mole of atoms, or molecules, is a perfectly manageable quantity to be used in a reaction. How do we use the mole in chemical calculations? Recall that Avogadro's number is defined as the number of atoms in exactly 12 grams of carbon-12. This means that 12 grams of carbon-12 contains 6.022 times 10 to the 23rd atoms. It also means that 12.01 grams sample of natural carbon contains 6.022 times 10 to the 23rd atoms, a mixture of carbon-12, carbon-13, and carbon-14 atoms, with an average atomic mass of 12.01. Since the ratio of the masses of the samples is the same as the ratio of the masses of the individual components, the two samples contains the same number of atoms. To be sure this point is clear, think of oranges with an average mass of 0.5 pounds each, and grapefruits with an average mass of 1 pound each. Any two sacks for which the sack of grapefruit weighs twice as much as a sack of oranges will contain the same number of pieces of fruit. The same idea extends to atoms. Compare natural carbon and natural helium. A sample of 12.01 grams of natural carbon contains the same number of atoms as 4.003 grams of natural helium. Both samples contain 1 mole of atoms. Table 3.1 gives more examples that illustrate this basic idea. Thus, the mole is defined such that a sample of a natural element with a mass equal to the element's atomic mass expressed in grams contains 1 mole of atoms. This definition also fixes the relationship between the atomic mass unit and the gram. Since 6.022 times 10 to the 23rd atoms of carbon, each with a mass of 12 units, have a mass of 12 grams. This relationship can be used to derive the unit factor needed to convert between atomic mass units and grams. Aluminum is a metal with a high strength to mass ratio and a high resistance to corrosion. Thus, it is often used for structural purposes. Compute both the number of moles. To do chemical calculations, you must understand what the mole means and how to determine the number of moles in a given mass of substance. These procedures are illustrated in example 3.3 and 3.4. The silicon chip used in an integrated circuit of a microcomputer has a mass of 5.68 grams. How many silicon atoms are present in the chip?